Okay, working on number 12 here of the homework for 8.4, continuing this. All right, we have tangent of t plus cosine t over 1 plus sine t equals secant t. All right, start with the left-hand side. Let's see here. Let's rewrite tangent as sine over cosine here on the left side. Okay, and then let's get a common denominator. So let's multiply the left side by 1 plus sine t over 1 plus sine t. Let's multiply the right side by cosine t over cosine t. And let's see what happens. All right, so when we distribute the sine through here, we get sine t plus sine squared t. Then we have the plus, these two multiply, that's cosine squared t. And then on the bottom, we've got 1 plus sine t. And then we have the cosine t. Let's not put those together, because what I'm saying is that these two is a Pythagorean identity, that's just plus 1. So the top is sine t plus 1 over the factor 1 plus sine t cosine t. And these cancel out, we get 1 over cosine t, which is the right-hand side. All right, good. All right, so establish this identity, cotangent theta plus tangent theta over cotangent theta minus tangent theta equals 1 over cosine squared theta minus sine squared theta. All right, I'm going to do the whole left side in terms of sine and cosine. So I have cosine theta over sine theta, that's cotangent, plus sine theta over cosine theta, all over cosine theta over sine theta minus sine theta over cosine theta. All right, let's put the numerator together. So that means we'll have to multiply cosine theta here, cosine theta here. We'll have to do sine theta here, sine theta here. Let's do the same thing on the bottom. Cosine theta here, cosine theta here, sine theta here, sine theta here. And let's put it together. So when I put those together, I get cosine squared, and then the plus, and then the sine squared. So I have cosine squared theta plus sine squared theta. That's going to be a 1 over the common denominator, which is cosine theta, sine theta, over, now when I do these two together, I get cosine squared theta minus sine squared theta. That is not 1. And then over cosine theta, sine theta. Now we have a fraction over a fraction, so I can flip and multiply by the reciprocal. So I can take this fraction, flip it over, put it up here. So the denominator is cosine squared theta minus sine squared theta. And good things are going to happen here. We get this cancels, that becomes a 1. So all you're left with is 1 over this, which is that. All right. Okay, this one, cotangent u minus tangent u over cotangent u plus tangent u. This is a lot like the last problem. Oh, plus 1, didn't see that, plus 1 equals 2 cosine squared u. Okay, let's do the same thing here. We've got cosine u over sine u minus sine u over cosine u over cosine u over sine u plus sine u over cosine u plus 1. Okay, so let's get a common denominator here. So we need cosine u here, sine u here, sine u here, cosine u here, cosine u here, sine u here, sine u here. And then the top becomes, let's see, cosine squared u minus sine squared u. That is not 1. Cosine squared u minus sine squared u over the common denominator, which is going to be cosine u sine u. All that over. Now this one does become 1. Cosine squared u plus sine squared u. That's 1 over cosine u sine u. Okay, I can flip this up. Cosine u sine u over 1, and then these cancel. And so I'm left with cosine squared u minus sine squared u, but I still have the plus 1. Oops, I've got the plus 1 here, plus 1. So we have, let's see, let me see where we are. We are at cosine squared u minus sine squared u plus 1. And I need this all to be cosine squared. So I'm going to use the Pythagorean identity on this. I have cosine squared u minus, now that becomes 1 minus cosine squared u plus 1. And when I distribute the negative sign through here, I get minus 1 plus cosine squared u. Then we still have the plus 1. The ones cancel. And I have cosine squared u plus cosine squared u, which is 2 cosine squared u. Okay. Okay, next one. Cosine theta minus cotangent theta over cosine theta cotangent theta equals tangent theta minus secant theta. All right, let's go. Everything in terms of sine and cosine. Let's go for that. Minus cosine theta over sine theta. So that's the cotangent right there. Over cosine theta times cosine theta over sine theta there. Okay, we'll put the 2 on top together. So I need a sine theta here, sine theta here. That's all I need to get a common denominator. So the top becomes sine theta, cosine theta, minus cosine theta. That's these 2 together, and then minus that one. And then over the common denominator, which is just sine theta. But then all of that over these 2 together, that's cosine squared theta over sine theta. And now I can flip this one, put it up here, sine theta here, cosine squared theta here. These sine thetas cancel. And so I'm left with, on top, a sine theta, cosine theta, minus cosine theta, all over cosine squared theta. That's this one right here. And now notice I can factor a cosine out of top since they both have a cosine. So that leaves me with sine theta minus 1 on top right there, and cosine squared theta. Now this bottom is really cosine squared theta is really cosine theta times cosine theta. That's what it means. So one of the cosines cancels. So I get sine theta minus 1 over cosine theta. Now that doesn't look exactly like this, but if we split this now into 2 fractions, I can do sine theta over cosine theta, and then minus 1 over cosine theta, and that's tangent theta, and then minus, and that's secant theta. So that does equal this. Okay, so cotangent theta over secant theta plus 1 equals secant theta minus 1 over tangent cubed theta. Now this one says to start with the right-hand side. Okay, so let me rewrite the right-hand side as secant theta minus 1 over, I'm going to write that as tangent theta times tangent squared theta, because tangent squared is something I have a Pythagorean identity for. This becomes secant theta minus 1 over tangent theta times, now I'm gonna use Pythagorean identity, tangent squared theta plus 1 equals secant squared theta. So if I move the 1 to the other side, I get minus 1. So I'm going to rewrite that tangent squared theta right there as secant squared theta minus 1. Ah, I see. Okay, so now secant theta minus 1 over tangent theta, difference of squares right there. That's secant theta plus 1, secant theta minus 1. And if I do it that way, then I can get this and this to cancel. And so I'm left with, I'll do it over here, I'm left with the 1 on top, and then I get tangent theta, and then times secant theta plus 1. And now all they're doing now is, since you have 1 over tangent, I can rewrite the tangent on top as cotangent of theta, and then that's your left-hand side. All right. All right. Okay. Cosine theta plus sine theta. I've been dreading this homework assignment because I know it's so much work. Okay, over sine theta minus cosine theta minus sine theta over cosine theta. We want all of that to be equal to secant theta. My hand hurts. Cosecant theta. All right, so I'm going to get a common denominator on the left. So I'm going to have to multiply cosine theta here on top and bottom. And that'll multiply through the top there. And then on this one, kind of out of room here, I'm going to do sine theta on the top and bottom. So I'll have to distribute through the top. So let's just do this. We got this, and then I'll have to do this. So I'm going to get cosine squared theta plus sine theta cosine theta. That's just these two. Then minus, now what? Minus what? Well, the sine goes through here, so I have sine theta cosine theta. And then here to here, there's a minus sign there, so minus sine squared theta. All of that over the common denominator, which is the sine theta cosine theta. Now, let's distribute the negative through here, and I'm going to do a shortcut. I'm going to just erase this parenthesis. That'll become a minus, and this one will become a plus, like that. And then this, and this become a 1. These two cancel, and so I'm left with 1 over sine theta cosine theta, almost there, which is equal to 1 over sine theta times 1 over cosine theta. But that's cosecant theta times secant theta. And that's the left, or the right-hand side. Written the other way around, but it's the same thing. Three more. I can do it. All right, so cosine squared theta minus sine squared theta over 1 minus cotangent squared theta equals sine squared theta. This seems like it's going to be easy. Something nice is going to happen, maybe. I feel like getting everything in terms of sine and cosine, but I really feel like I should turn that into something with sine in it also. So using the Pythagorean identity on that, I can rewrite that as 1 minus sine squared theta. That's what cosine squared theta is, and then minus sine squared theta. And on the bottom, rewrite that as 1 minus cotangent is going to be cosine squared theta over sine squared theta. This doesn't seem right. Something doesn't seem right. All right, I'm just going to keep going. All right, this equals 1 minus 2 sine squared theta over, okay, here if I get a common denominator, I have to multiply top and bottom here by sine squared theta. Oh, I see. Oh, I see it. Okay. So this top will become sine squared theta. That's this times 1, and then minus cosine squared theta over the common denominator, which was sine squared theta. See, I'm feeling like maybe I should have just left this alone and not turned it into the other one. Let's do that. Let's leave the top alone. Let's leave that as, oh, you know what I forgot in the original problem? There's a minus sign in front of that sine squared. Yeah, I can see that was going to be right. So the top is cosine squared theta minus sine squared theta. And now watch. This is like a big division bar right here. So I can look at this as being cosine squared theta minus sine squared theta. That's the top fraction over 1. But then over the other one, sine squared theta minus cosine squared theta over sine squared theta. And then because I've got this big fraction, I can multiply by the reciprocal of this. So sine squared theta on top. Now on the bottom, sine squared theta minus cosine squared theta. And then these almost cancel. Okay, this and this almost cancel. They're just off by a sign. So if I pull a negative out of this one, it'll change that to negative and that to plus, and then they can cancel. And you're left with the negative that was here and the sine squared that was there. And that'll give you negative sine squared theta. Quick pause here. Okay, on this one, we've got cosecant alpha plus cotangent beta. Okay, so this is the first time we've had different variables in here. Sine alpha plus tangent beta. Show that that equals cosecant alpha cotangent beta. Okay. Get it all terms of sine and cosine. So cosecant of alpha is 1 over sine of alpha. Cotangent beta is cosine of beta over sine of beta. And then I have sine alpha plus now sine beta over cosine beta. All right, I think no choice but to get a common denominator here. I'm gonna have to multiply top and bottom here by sine beta over sine beta. And then this is over 1, so I'm gonna do cosine beta here, cosine beta here. So I go here to here, I get sine beta, then the plus, and then cosine beta over the common denominator, which is gonna be sine beta, sine alpha, over, okay, cosine beta times sine alpha, so cosine beta times sine of alpha, plus, that's this, sine of beta, then all over the common denominator, which is cosine squared beta. Oh, man. Oh, you know what I'm missing? I think I'm missing here. I did this common denominator. I needed sine alpha, sine beta. So I did sine beta here. I forgot to do sine alpha here. Yeah, I forgot that one. So that's going to give me a sine alpha here. Ooh, wait a minute. Those are the same? No. This, and this are the same. So when I do multiplication of the reciprocal of this, I bring the cosine squared beta on top. On the bottom, I have the cosine beta sine alpha plus sine beta. And that should cancel with this exactly, which leaves me now with this piece and this piece. So I have to do it over here. I have cosine squared beta over sine beta sine alpha. Something ain't right. Something ain't right. Was that a cosine squared? Hold on. Oh, yeah, no, I see the problem. Okay, sorry. When I put these two together, I don't know why I put cosine squared beta. That's the common denominator is cosine beta. So that's not a squared, which means that's not a squared, which means over here, this is just a cosine beta, not cosine squared. Okay, sorry about that. Okay, now we're here because it's cosine beta over sine beta. That's cotangent beta. And then we still have like a 1 over sine alpha here, but 1 over sine is cosecant alpha. And that's this side right there. Okay. Getting there. Oh, last one. I'm happy. I'm happy. Sorry, I'm moving so fast through this. I just have so much to do. Okay. All right. Cosine of alpha plus sine of beta squared plus sine of beta plus cosine of alpha times sine of beta minus cosine of alpha. Make sure I got this all written down right. Cosine alpha plus sine beta squared plus sine beta plus cosine alpha times sine beta minus cosine alpha equals 2 sine of beta cosine of alpha plus sine of beta. All right, let's try this left-hand side. So I'm going to square this. So I have to multiply it times itself. I'm not going to show that. I'm going to trust that you could FOIL this out. This is cosine squared alpha plus 2 cosine alpha sine beta. And then we have plus sine squared beta. Okay, that's what happens when you do this step. Then I have to do this multiplication. So I'm going to FOIL out here. So this is going to be plus sine squared beta. Now this times this and this times this, those cancel. Okay, because those are exactly opposite of one another. It's sine beta cosine alpha, or sorry, negative sine beta cosine alpha, then plus sine beta cosine alpha. So those cancel. So all we get is that and that. That's minus cosine squared alpha. Okay, do I get anything nice here? Oh, well, I do. I get those cancel. And then, let's see, sine beta squared. So I have here 2 cosine alpha sine beta plus, there's 2 of these, 2 sine squared betas. That's those 2 together. And now I can factor out of those a 2 and a sine beta. If I factor that out, I'll be left with a cosine alpha there. Plus, I factor the 2 and I factor one of those out, so I'm still left with a sine beta there. And that's this. Yay, I did it. Okay, I made it to the end. I'm happy. Hope that helps.